Okay, so today we're going to be talking about solving systems of equations. There's three different possible answers that you could get for solving systems. Whenever you're solving systems of equations, you are trying to find a solution, and a solution is the point of intersection of those two lines. And normally you'll get x equals a number, and then you'll get y equals a number, and you'll put it together as an ordered pair because it is a point on that line, okay? What also can happen is that the two lines actually intersect so much so that they are on the same line. And notice that every point on both of those lines is an actual intersection. This is known as infinite solutions, okay? And you will always get a true statement. 0 is equal to 0, 4 is equal to 4, or so on when you're doing it mathematically, and that will tell you that it is an infinite solution, okay? You can also have two parallel lines that will never intersect, and this is a no solution, all right? In your no solution, you'll get a false statement. 2 is not equal to 4, and that is how you know that it's a no solution, all right? First, I want to talk about substitution method. Now, I know we just did one in our warm-up, so I'm just going to do one of these on here. In substitution method, you are trying to get one of your equations in x equals or y equals. The way you know that is because in one of your equations, you have a coefficient of 1 for one of the variables. In this problem, our second equation has a coefficient of 1 for our x. So I can subtract 3y here, and that gives me x equals negative 3y plus 3. Okay? There I've solved for x. What I'm going to do with this information is because I have x equals something, I'm going to plug it in for x in my first equation. Okay? So it's now going in the other equation. So now my first equation will read 2 times negative 3y plus 3 plus 5y is equal to negative 5. So notice I went ahead and finished out the rest of it. So I only put this in place of the x. Notice now I only have a y in my equation. So now I can solve for y. When I distribute, I get negative 6y plus 6 plus 5y is equal to negative 5. This gives me negative 6 plus 5 is negative y plus 6 equals negative 5. When I subtract 6, I get negative y is equal to negative 11. When I divide by negative 1, I get y is equal to 11. I'm going to take that and I'm going to plug it in up here for x equals. So now I have x equals negative 3 times 11 plus 3 gives me negative 33 plus 3. So x is equal to negative 30. So my answer is going to read negative 30, comma 11. Okay, you have to plug it back into the second equation, and I always plug it into this one that they give me since I'm solved for x. All right, now let's look at elimination method. Elimination is a little bit different. Okay, elimination, you are eliminating either the x values or the y values. Okay, you have to make sure that both of your equations are in standard form. Okay, so looking at example 3, my first equation both has my x and my y on the left-hand side. My second equation, this is negative 6x. I need to add this over to get it on the other side. So now, whenever I look at it, my first equation reads 3x minus 7y is equal to 10. You always want to kind of make sure they're lined up together. My second equation is 6x minus 8y equals positive 8. Now, in order to eliminate, I can either eliminate the x's or the y's. I want them to have the same coefficient but opposite sides, the same number. This is a 3, this is a 6. I can multiply this by 2 and make it a 6 and eliminate my x's. Now, I don't want it to be a positive 6, I want it to be a negative 6. So I'm going to multiply this by negative 2. So my first equation will read negative 6x plus 14y equals negative 20. My second equation is 6x minus 8y equals 8. So remember, in your elimination method, you're always adding them together. My 6x's cancel out, and I get 6y equals negative 12, and I divide by 6, and I get y is equal to negative 2. when I plug it in for elimination, it doesn't matter which one I plug it into, okay? So if I plug it into the first one, I have 3 times negative 2 minus 7y equals 10. This gives me negative 6 minus 7y equals 10. And when I add 6, let's see. Did I have this right? Yeah. Well, add 6, negative 7y equals 16, and divide by negative 7. I think I got off somewhere. Negative 12, negative 2. This is y. I plugged it in for x. 3x minus 7 times negative 2 here. I'm sorry. So this will give me 3x plus 14 equals 10. Subtract 14, and I get 3x is equal to negative 4. Divide by 3, and I get negative 4/3 for x. So my answer is negative 4/3, comma, negative 2. Okay? Alright, so that is elimination method, which we've done a lot more of. I will tell you to do some of them with just substitution, some of them with just elimination, and then some I'll ask you to do either or. This example right here is probably easiest to do substitution method because it's already got a coefficient of 1. If I add 2y over, then I get x equals 2y plus 4. When I take this and plug this into my first equation, or second equation, I have 3 times 2y plus 4 minus 6y equals 8. So when I distribute, I get 6y plus 12 minus 6y equals 8. My y's actually cancel each other out, and I get 12 is equal to 8. Well, we know 12 is not equal to 8, so that is actually a no solution. Okay? Alright, so that's how that'll work out when you get a no solution. Last one over here, I'm going to move this over and I'm going to do elimination method. So right here I get 2x minus 5y equals 4. And right here for my second equation, to eliminate, I'm going to multiply my top equation by 7. So when I do that, 7 times 2, that gives me 14x minus 35y is equal to positive 28. Well, look, I already have my second equation written here. Notice what happens. This cancels out, they all equal 0. Well, 0 is equal to 0. That's a true statement. This is actually an infinite mini solution. Okay? And there's your answer.